Download this code from codegive.com, link in the description below. Don't make this dependency injection mistake, over-abstraction and the concrete abstraction. Dependency injection, DI, is a powerful technique for writing testable, maintainable, and loosely coupled code. However, like any powerful tool, it can be misused, leading to a common pitfall, over-abstraction with concrete abstractions. This tutorial will explain what this mistake is, why it's harmful, how to identify it, and how to avoid it, complete with code examples in C, but the concepts are applicable to other languages like Java, Python, and JavaScript. What is over-abstraction with concrete abstractions? This mistake occurs when you introduce an abstraction, typically an interface, where it's not actually necessary or provides no real benefit, and then specifically bind a concrete implementation of that interface everywhere without considering other possibilities. It boils down to creating an interface merely for the sake of using an interface, not because you genuinely anticipate having multiple implementations or needing to swap them out. Why is over-abstraction harmful? 1. Increased complexity *, adding unnecessary abstractions adds layers of code, increasing the overall complexity of the system. More classes, more interfaces, and more code to navigate make the code base harder to understand and maintain. 2. Reduced readability *, the extra layers of abstraction can obscure the purpose of the code. Instead of directly seeing what a class does, you have to jump between the interface definition and the concrete implementation to understand the behavior. 3. Maintenance overhead *, every time you need to make a change, you now have to consider both the interface and the concrete class. Small changes require more files to be modified, increasing the risk of introducing errors. 4. Premature abstraction *, this kind of abstraction is often done before a real need is identified. You're essentially anticipating a change that might never happen, and you're paying the price of the abstraction upfront without any tangible benefit. 5. False sense of security *, developers might think they're making their code more flexible and testable by using interfaces, but if the application is always going to use the same concrete implementation, the abstraction becomes largely useless and can even make testing more complex in some cases. Illustrative code example, C. Let's consider a simple example of an email service. A common mistake is to create an interface email service and a concrete implementation SMTP email service. The problem *. In this example, we've created an email service interface and a concrete SMTP email service class. The registration service depends on the email service interface. This looks good on the surface, but, in the composition root, or the dependency injection containers configuration, we're always binding email service to SMTP email service. We always use SMTP email service. The email service interface is essentially acting as a thin wrapper around SMTP email service. There's no real intention of ever using a different implementation of the email service. We've added an extra layer of indirection without any clear benefit. How to identify over-abstraction? Single concrete implementation *. Do you only have one concrete class that implements the interface? Always the same binding *. Are you consistently binding the interface to the same concrete class in your DI container configuration? No anticipated variations *. Do you foresee any realistic scenario where you would need to swap out the implementation of the interface for another one? Minimal interface *. Is the interface just mirroring the methods of the concrete class, providing no additional abstraction or specialization? Just in case abstraction *. Are you creating the interface just in case you might need it later, even though there's no current need? If you answer yes to most of these questions, you might be falling into the trap of over-abstraction. How to avoid over-abstraction. 1. KISS, keep it simple, stupid. Start simple. Don't introduce abstractions prematurely. If you only have one concrete implementation, start by using that concrete class directly. 2. Yagna, you ain't gonna need it. Don't add features or abstractions that you don't currently need. Wait until you have a clear requirement for a different implementation before introducing an interface. 3. Favor composition over inheritance. While not directly related to this specific mistake, preferring composition encourages creating loosely coupled and easily testable classes without necessarily needing interfaces at the outset. 4. Consider a concrete class instead. In the email service example, if you're only ever going to use SMTP, consider removing the email service interface and directly injecting the SMTP email service class into the registration service. 5. Refactor when needed. If you later find that you do need a different email service implementation, example a mock service for testing or a service that uses a different provider, then introduce the interface and refactor the code. Revised code example, avoiding over-abstraction. Instead of using the interface prematurely, we can directly inject the SMTP email service. This revised code is simpler and more direct. It avoids the unnecessary complexity of the interface and makes it easier to understand how the registration service sends emails. When to introduce abstraction, and why it's important. Then you should introduce an abstraction, like an interface, when you have a real need for it. Here are some valid reasons. Multiple implementations. You have, or anticipate having, multiple distinct implementations of the interface. For example, you might have SMTP email service for production and mock email service for testing. Testing. You need to mock or stub the dependency for testing purposes. This is often a primary driver for and interfaces. Extensibility. You want to allow other developers to extend your code by providing their own implementations of the interface. Decoupling. You need to decouple components to improve maintainability and reduce dependencies. Example, adding a mock email service for testing. Now, let's say you want to test the registration service without actually sending emails. Now is the time to introduce the email service interface. Now, we have a legitimate reason for the email service interface, to provide a mock implementation for testing. The D container can be configured to use mock email service in testing environments and SMTP email service in production. Key takeaways. Don't over-abstract. Introduce abstractions only when you have a clear need for them. KISS and Yagna, keep your code simple and avoid adding features or abstractions prematurely. Start with concrete classes. Refactor to introduce abstractions when necessary. Testing is a key driver. Use interfaces to facilitate testing by allowing you to mock or stub dependencies. Realize the cost. Remember that abstractions always add complexity, and weigh that cost against the benefits they provide. By avoiding the concrete abstraction trap, you'll write cleaner, more maintainable, and more understandable code that leverages the power of dependency injection without the unnecessary overhead. Good luck.